Hi students, in this video we will talk about Lab 7, restaurants, and hopefully it will give you some good advice as to how to solve this problem. So let's get started with part 1, the menu. Begin the program with a vector that contains 8 restaurants, all of which should be real. So when you're initializing your vector in the program, you need to add to it 8 real restaurants. And just by doing that, you get a few free points. Next, you will prompt the user to select one of several options, and those options are shown here. Next, after any operation is complete, reprompts the user to select the next operation. So basically, this whole concept of the menu is something that you've been doing since Lab 4, so that should feel pretty comfortable right now. We won't take too much extra time to explain that. You should expect the user to input, right here, 1 through 6 to signify their menu choice. So in this lab, as far as the menu is concerned, you can expect us to input only 1 through 6. We won't put anything unexpected or invalid in. For part 1, only the quit option needs to work. Okay, so we've covered the menu, and let's skip down to part 2, the contenders. So the first part of this is to add functionality to the first 4 operations given in the menu. And those are display all restaurants, add a restaurant, remove a restaurant, and shuffle the vector. So let's talk about display all restaurants, option 1. And this requirement says display the restaurants in their current order. So in their current order would mean vector element 0, vector element 1, etc., until you reach the end of the vector. And let me demonstrate to you what my version of the code does. So you see my menu right here, and then you can see 1, display all restaurants, and it lists 8 real restaurants. They're separated only by a comma, but you'll notice that the last restaurant does not have a comma after it. Okay, so great, that part works. We can see that there are 8 restaurants in the vector at the current time. The next option, add a restaurant. You must prompt the user for a restaurant name. If the restaurant is already in the vector, add it to the vector. Sorry, if the restaurant is not already in the vector, add it to the vector. If the restaurant is already in the vector, do nothing. In either situation, inform the user what has happened. Okay, so let's try to add first something that's already in the vector. So you can see Burger King is already included. So if I try to add something that's already in the list, we'll say the restaurant is already in the list. And if we display, then we can see that we do not have 2 copies of Burger King inside the vector. Great. So then let's add something that is not inside of that vector. Let's try Rancheritos. It says added restaurant to the list. And we can see right here that we now have a total of 9 restaurants in the vector. Okay, great. So the add part is covered. One additional requirement that we have for that is you must use a find function described in the pass-off requirements section below to receive credit for this part. And your add function, of course, must be its own separate function. So the next part, remove a restaurant, prompts the user for a restaurant name, just like we did above. If the restaurant is in the vector, remove it from the vector. If the restaurant is not in the vector, do nothing. In either situation, inform the user what has happened. So this is pretty similar. Let's try first to remove something that is not in the vector. So chef's table is not in there. You should see that our total list of restaurants is unchanged. Okay. So then let's remove Rancheritos, because that is a restaurant in the vector. And after pressing 1 again to display the restaurants, we see Rancheritos is now gone. Okay, great, so that's the remove. The next part, shuffle the vector. Randomly rearrange the restaurants in the vector to help remove bias from the tournament. So shuffle ideally is going to move all of the restaurants inside the vector to a different position, and this position should be random. One requirement we have for this section is that you may not use any of the standard library functions except for the random number generators. So right there we also give you a tip. You should be using random number generators to implement your shuffle algorithm. Okay? Just remember that you cannot use the random shuffle function provided by the vector class. We want you to make your own. Okay? So let's look at what that does. right here we see the current order: McDonald's, Burger King, Taco Bell, Wendy's, etc., etc. If I shuffle those, make this a little bigger, you can see that these restaurants have changed order, they've changed their positions. Okay? And those positions are going to be important when we get to part 3, the battle. So part 3, allow the user to run a tournament among the restaurants currently in the vector and report the winning restaurants. Each match of the tournament involves displaying 2 restaurants to the user, prompting him to choose his favorite, and removing the losing restaurant from the tournament. You should expect the user to input either 1 or 2, signifying they prefer either the first or second restaurant respectively. However, if the user provides a response that is neither of the restaurants in the current match, so if the user enters something that isn't a 1 or a 2, reprompt the user until valid information is entered. Okay? As a reminder, for each round, each restaurant must appear exactly once per each round. So if a contestant appears in multiple rounds, it means something isn't working correctly with our program. We'll give you a couple examples of that in the demonstration. Do not allow the tournament to begin unless the number of restaurants is equal to 2 to the n for some value of n is greater than 0. So for this last part, we're just checking to see if the number of restaurants inside the vector is equal to 2 to the n for some value of n is greater than 0. So to be able to start this option, option 5 in the menu, you must have a total restaurant size of 2, 4, 8, 16, 32, 64, etc., etc. Okay, you cannot use if statements to accomplish this check. You must have an algorithm for solving this part. Okay, so now we're going to give kind of a more detailed description of how this tournament should actually work. Okay. So right here we have a little animation, and we can see here are all the restaurants in our vector. We have McDonald's, Burger King, Taco Bell, Wendy's, Sonic, Panda Express, Chick-fil-A, and Burger Supreme. These 1s and 2s are really just to help us when it comes down to each individual match. Okay, so this is how the tournament's going to start, and we can see that this is round 1 out of 3. Okay, so let's keep going. So for the first match, McDonald's or Burger King, because this is that top left bracket, the computer should prompt what's shown in the black text: 1 McDonald's or 2 Burger King. So if I enter 2, signified by that red 2, Burger King should advance in the tournament, and McDonald's will be eliminated. So this would be match 1 of 4 for round 1 of 3. There are 3 rounds, and this first round has 4 matches inside of it. You can see the 4 matches here, okay, given by each parent. Okay, so let's go to the next one. You can see the text that would display in the console, which would be 1 Taco Bell or 2 Wendy's. If I enter 2, Wendy's should progress and Taco Bell will be eliminated. Okay, so then let's go to match 3, Sonic or Panda Express, we choose Panda. And then the next one, Chick-fil-A, Burger Supreme, we choose Burger Supreme. Okay, so that's going to be it for the first round. Let's see what's happened. Okay, we see Burger King, Wendy's, Panda Express, and Burger Supreme have all progressed. Okay, where McDonald's, Taco Bell, Sonic, and Chick-fil-A have been eliminated. So there are a lot of different ways to do this, but if you think about it, the easiest way to conceptualize this would be having McDonald's, Taco Bell, Sonic, and Chick-fil-A being taken out of the list of restaurants. Okay, so then after round 2, let's say we choose Wendy's and Panda Express, and then once again, Burger King and Burger Supreme are eliminated. We're ready to go to the last round, and we ultimately choose Panda and the tournament's over. Okay? So that is the conceptual explanation of what should be happening in a tournament. And the last thing that we're going to do is we are going to give a demonstration of the battle. The first thing that we want to check, what's going to happen if my tournament size is not a multiple of 2 to the n. So let's just remove something just to make sure that this function works. This check works. So now we have 7 restaurants. And if I try to begin the tournament, it won't let me. Okay, so then I need to add Wendy's back in or some other restaurants that I have a valid tournament size. Let's go with begin, and we see exactly what the animation just showed us. 1, Panda Express, or 2, McDonald's. This section right here is going to be the extra credit part, and that's explained more thoroughly in the requirements of the lab. So let's say we just go 1, 2, 1, 2. So then Panda Express, Taco Bell, Sonic, and Wendy's should still be in the tournament. So we see Panda, that's good, and we see Sonic and Wendy's. Okay, so those are both correct. Okay, and then let's choose Panda. Okay, so that is the explanation for Lab 7. Please remember that we give you tips for good coding style and the qualitative points that are associated with those bullet points, and we give you an option for the extra credit. Where am I? And the extra credit it's shown briefly in the code that we just ran and in the animation that was shown in this PowerPoint. Please also pay attention to these requirement notes, as they will be required before you can get credit for your lab. Good luck, students. Let us know if you need any help.